Fire is a combustion reaction where two necessary resources are needed to keep the fire burning: oxygen and fuel. One example of fuel could be gasoline, wood, or as simple as a hemp thread. But just because the object is surrounded by oxygen does not mean that the object will combust into flames. For the combustion reaction to happen, the object has to be heated to its ignition temperature. Different flammable fuels catch fire at different temperatures. If the hemp thread is highly flammable, then a longer hemp thread will burn faster because the surrounding oxygen will speed the process, and the long thread will keep the fire burning stronger than a shorter thread.
After measuring the burning time of different string lengths, we had to multiply the x and y variables to find what x squared was and what y squared was. We were able to find SSX, SSY, and SSXY. After finding what those variables were, we plugged them into a formula to find the v variable in the regression equation, and afterwards we can find the a variable. The regression equation helps us find the best fit line by plugging in all x's into the equation. SSX, SSY, and SSXY also help us find R. R tells us how much of the correlation the variables have, and R squared tells us what percent of Y variables depend on. For our experiment, we burned different sizes of string and recorded the time it took for it to burn to see if there was any correlation between string length and burning time. The x variable or dependent variable was the string size, as we decided how much string we were going to burn after each trial. The y variable or independent variable was the time the string took to burn. This variable was the one that we were measuring, and we didn't know the outcome of it, as it strongly depended on the string length.
Correlation and Determination Coefficients and Their Interpretations by Sebastián González. Correlation coefficient. Since R equals 0.99, this means that there is a very high positive correlation between the size of the string and the total seconds that it takes for them to burn. Coefficient of determination. Since R squared equals 0.98, this means that 98% of the total seconds that it takes for the string to burn depends on the size of the string.
With our experiment, we had a result for R of 0.99, which is really close to 1, and this signifies that it was a very high positive correlation. You can see it in the graph as it is a high positive correlation, and in the second graph with Y1, it stayed almost the same, and this is because the correlation was so high that it was just like the first one.
Every time that an inch of the string is increased by 1, the time given of the burn will increase by 1.67 seconds. Starting in the 136, this means that this is the y-intercept.